Welcome back, Eastview Scholars, to the second in our ionic naming series of videos. Today we're going to look at ternary, or what are called polyatomic compounds. And these are compounds as opposed to the binary that we just talked about that have only two elements in the compound. These have three or more, and that leads to a little bit of differences. Now, you might ask yourself, why do we have all these different styles? Well, remember, there's only 92 naturally occurring elements, and not all those are abundant. And there's billions of compounds out there. So you need to have ways to have variety. Ternary compounds are still written cation, anion. It's still a metal and a nonmetal. What you notice, though, is a nonmetal is a group of elements for the most part. And let's give you an example. Here is the basis of a lot of shells, calcium carbonate. You can see you have calcium, carbon, and oxygen. What becomes confusing in polyatomic or ternary compounds is where is the positive and where is the negative half. Now, 99% of the time, the first element is going to be your cation, and the rest of this stuff is going to be your anion. And this is what the polyatomic portion is. What does it mean to be polyatomic? Well, what it means is, and what may help for Eastview students, is to get out your periodic table, and right underneath the periodic table cheat sheet is a box listed as polyatomic ions. It's certainly not every one there is in the world, but there's plenty. And what you notice is they are combinations, for the most part, of nonmetals. A lot of carbon, a lot of oxygen, some nitrogen, and stuff. But a couple things you should notice is that they are nonmetals, so they're going to be covalently bonded, not ionically bonded. For the most part, with very few exceptions, they're all negative because they're anions. The one positive polyatomic that we will work with always is ammonium, which is on your sheet, the very first one, which is NH4, which has a positive 1 charge. So your identifying factor is, unless you see ammonium starting off a compound, it's going to be the very first element. The rest will be your anion. Now, what do I mean by covalently sharing? Well, here's carbonate. Here it is broken down into its carbon and its 3 oxygens. Carbon has 4 valence electrons. Each oxygen has 6. And these are not going to ionically bond because carbon doesn't. It's just a covalent. All it does is covalent. And oxygen could bond ionically, but it's a negative ion. But they can share electrons. Okay? So we can easily see, and let me do a couple things here. We can easily see that you could share these electrons, and I'll indicate that as a bond by drawing a line through them. We can also share here, and we can share here. And the goal of sharing is always to share enough electrons that everybody's at that stable configuration of having 8 shared in their outer electrons. Well, I'm getting there, but I certainly haven't shared. But I have a carbon electron I haven't used here, and pick any one of the oxygens, which has another one that I haven't used, and I'll just pick the one on the right. What I'm going to do is I'm going to erase this one, and I'm going to erase this one, and sorry, I used too big an eraser, so let me fix this a little bit and make that look like an oxygen. But what I've done there is, what I'm going to pretend is that those two slid over and started to share here too. So this would have a double bond. Now, that gives this one 2, 4, 6, and 8. Each line is 2 electrons. Okay, that gives carbon 2, 4, 6, 8 electrons. But these 2 oxygens are still missing an electron to make them happy. But oxygen is very electronegative, so it certainly could pick up, as kind of an ionic compound would, a couple of negative ions. And that then denotes the carbonate polyatomic ion, which is a carbon 3 oxygens, and it has a negative 2 charge because it picks up those extra 2 electrons. That's how a polyatomic comes together. That's how all those on your cheat sheet look. And they do that just to add variety. Okay? So ternary or polyatomic compounds contain 3 or more elements. Polyatomic ions are groups of elements, often including oxygen, that are covalently bonded, and they've also picked up extra electrons to fill their shells, and that allows them to behave. Now, with only 2 exceptions that we work with, hydroxide and cyanide, an identifying feature of polyatomic compounds is they end with an AT or an IT ending. Okay? And as we'll see in writing the formula, parentheses are very important. So, let's look at some examples. Again, the thing to decide is where is the positive and the negative. And here it is. After the only time I know that it's not the very first element, like in these two, positive and negative, is when I start with this ammonium. Okay? So that's my identifying feature. I'm going to, for the most part, assume the first element is my cation unless I see this. At which point then the naming is pretty much standard. Ca is calcium, so I write that. And then I go to my cheat sheet, I see this mess, and granted it's in parentheses, but I know that this is my cation, so this has to be the polyatomic. And as I look it up, then my cheat sheet tells me that the name is nitrate. And I write it. No change in the ending, nothing along that line, just that's what it is, calcium nitrate. Here, lithium is going to be, it's the very first element, so I'm going to write lithium. And then I'm going to look up that what NO2 is on my cheat sheet of polyatomics. And that tells me that the name is nitrite. And then I just write it. Oops, my writing's a little... That word is nitrite if you can't read it. Here, I started with ammonium. So that's what I'm going to write. I'm going to write ammonium, and then I'm going to look up the rest. I apologize, the pen is really not flowing smoothly off the stylus today. Ammonium, and then PO4, I looked that up on my chart, and that's something called phosphate. Okay. So in a sense, once I identify that the first element is the cation, unless I see that ammonium, I just write what the words are. Okay. Now, for writing the formula, it's the same as we've done before. Lithium is Li. It's the first one. It's going to be positive. It happens to be a positive 1. And then seeing the ATE ending, I go to my polyatomic chart. I see that that is... CO3 is what carbonate is. It's a -2. And just like I did with the binary ionic, I can do a charge flip-flop. So I need 2 lithium for every carbonate. Okay. All right. Same thing here. Calcium is a +2. I look up nitrate, it's NO3 -1. Okay. Charge flip-flop. Now here's the thing. When I do the charge flip-flop for my subscript, it says I'm going to need 2 nitrates to attach to 1 calcium. That's when I have to bring in my parentheses that you see in some of the compounds above, surround that polyatomic ion with parentheses, and then give it the subscript 2. That tells me I have 2 nitrates bound to that calcium, and again, because ionic compounds are neutral, that evens out the charges and makes them 0. Last example we're going to do here is strontium hydroxide. Strontium is Sr +2. Hydroxide is one of our 2 polyatomics that ends in IDE, so I just have to learn them. And that's a -1. Hydroxide and its cousin cyanide, that are the 2 IDs, are the ones where the most errors come in, because if I do my charge flip-flop, I need to have 2 hydroxides, which I have to put in parentheses to denote that I have 2. The very common error is just to write strontium, OH, ooh, again, freewheeling pen today, and then a 2 right there. This is wrong. That denotes 2 hydrogens and 1 oxygen when really what I have is here. It's a very common error. Please don't do it. All right. Anyhow, other than that, other than identifying what that the first element is the cation, unless I see ammonium, I name it essentially like I do a binary ionic with the cation first, then the anion, but I don't have to change the end of the anion except in a couple of exceptions where it might be a chlorine element or something like that where I would change it to an IDE ending. Okay. There you go, ternary compounds. Scholar up, Eastview.